Hello and welcome. In this video, we're going to talk about special right triangles. That includes 45, 45, 90 triangles and 30, 60, 90 triangles. Our goal in this lesson is that we can use special right triangles to find missing side lengths in a triangle. Let's go ahead and jump in. All right, here we go. We have two types of special right triangles. The first is a 45, 45, 90 triangle, and we learned in a previous lesson that the length of the side corresponds to the angle. So if we have two angles that are congruent, that means we also have two sides that are congruent, which means we have x as the length for both sides. So if x is 5, then this side is 5, etc. If x is 7, then both sides are 7s. But we have an isosceles triangle, which means the two sides are going to be the same length. That's the first unique thing about this. If we then used the Pythagorean theorem to find the length of the third side, let's actually just go ahead and do this. This is sort of like a mini bonus proof here. We would say x squared plus x squared equals, for right now, I'm just going to call the third side the hypotenuse squared. So this would be 2x squared equals the hypotenuse squared. If we then take the square root of both sides, we would get that the square root of 2, so the square root of 2 times the square root of x squared, I can't square root 2 evenly, but I can square root x. And this would equal the hypotenuse. So to find the hypotenuse, you take the leg and you multiply it by the square root of 2. And that's what we're saying here. You don't need to know this proof. And in fact, you could really always just use the Pythagorean theorem to find the hypotenuse in this case because the two legs are the same side. But to find the hypotenuse, you take the length of one leg and you multiply it by the square root of 2. That is what the 45, 45, 90 triangles theorem says. To find the hypotenuse is root 2 times as long as each leg. The second triangle theorem in this lesson has to do with 30, 60, 90 triangles. And what it says is in a 30, 60, 90 triangle, the hypotenuse, actually I want that to be green, the hypotenuse is twice as long as the shorter leg. And remember that shorter leg will always be across from the 30-degree angle or opposite the 30-degree angle. And the longer leg, which is going to be the one across from the 60-degree angle, the longer leg is twice as long as the shorter leg. So we sort of have some formulas over here. To find the hypotenuse in a 30, 60, 90, I'm going to multiply the shorter side by 2. To find the length of the longer side, I'm going to multiply the shorter side by the length of root 3. We're going to get one more new piece of information, and then we're going to just work through a bunch of example problems. All right, sometimes when we're solving problems like these, we're going to end up with a radical in the denominator, and that's a big no-no. We are not going to leave an irrational number in the denominator. So what we're going to do is a process called rationalizing the denominator. And what we need to do, in this case, we're always going to be working with square roots. In Algebra 2 and pre-calculus, you'll do it with different types of roots, or even with expressions. But what we're going to do is we're going to multiply the numerator and the denominator of the fraction by that radical. So really all we're doing here is this root 7 over root 7 is just 1. It's kind of an ugly looking 1. But this allows us, if we multiply across the numerator and multiply across the denominator, we're going to get 3 root 7 over the square root of 49, which we can evenly root to get 3 root 7 over 7. This will always work if the denominator was root 14 and I multiplied that by root 14. I would get really just the square root of 14 squared, which is just going to give us 14. So this process of rationalizing the denominator is always going to work just like this. We're always going to end up with that number that was left inside. So now that we've talked about rationalizing the denominator and we've talked about the special properties of our special right triangles, let's look at some examples. All right, for each of these examples, I want to start by identifying which type of special right triangle it is, and I want to make sure I identify the hypotenuse. So the hypotenuse is always going to be across from that right angle. So on 1 and 2, I'm going to go ahead and just identify it right away, across from the right angle. On number 1, I can tell that this is a 45, 45, 90 triangle because I have one angle that has a measure of 45 degrees. What that means is both legs are the same length. and it means that the hypotenuse, which in this case is x, is going to be the leg times the square root of 2, and in this case, the leg is 8. So the length of the hypotenuse is 8 times the square root of 2. Now, if we tried this just using the Pythagorean theorem, we would get 8 squared plus 8 squared is x squared. 8 squared is 64. 8 squared is 64, and if I add those, I get 128. So x would be equal to the square root of 128, which, if you simplify, will also give you 8 root 2. But this strategy, understanding special right triangles, is going to make this process much more efficient. Okay, on number 2, we are given the hypotenuse. So in this case, the hypotenuse is 5 times the square root of 2. We know that the hypotenuse is equal to the leg times the square root of 2. So if we now solve for, actually, instead of writing the word leg here, let's write x. If we now solve for this, we can divide both sides by the square root of 2 to isolate x. That's going to give me that x must just be equal to 5. If we look at number 3, again, I want to start by identifying the hypotenuse. And I'm going to identify it also on number 4. And then I'm going to identify what kind of special right triangles these are. These are both also 45, 45, 90. So see if you can use the fact that we know that the hypotenuse is equal to the leg times the square root of 2 to find the value of x on each problem. And then unpause the video and see how you did. All right, hopefully you had time to work through these on your own. My first thought is I'm looking for x here. This is 10, and since this is an isosceles triangle, 45, 45, 90, they're both 10. So in this case, the hypotenuse, which is x, is going to equal to the leg, which is 10, times the square root of 2. So x is just equal to 10 square root 2. Okay, on number 4, the hypotenuse is 12, so both of these sides are x. So I know that the hypotenuse, which is 12, is equal to the leg root 2. In this case, the leg is x, root 2. So now, to isolate x, I need to divide both sides by the square root of 2. So that's going to give me x equals 12 divided by the square root of 2. Now comes the rationalizing the denominator. We're going to multiply the numerator and the denominator by the square root of 2. This is going to give me x equals 12 root 2 over root 2 times root 2 is root 4, and the square root of 4 is 2. And then I can simplify 12 divided by 2 is 6, so this is going to give me 6 times the square root of 2. So 45, 45, 90 triangles, the key thing to remember is that the hypotenuse is equal to the leg times the square root of 2. If you start with that statement, and if you keep writing it over and over again, it's going to ingrain in your mind, then you can find the piece that you're missing and solve for that piece. Let's look at some examples of 30, 60, 90 triangles. All right, here we have 4 examples that are 30, 60, 90 triangles. What I want you to do is to pause the video and highlight or identify the hypotenuse, the shorter side, and the longer side, remembering that the shorter side should be across from the 30-degree angle and the longer side should be across from the hypotenuse. All right, hopefully you took the time to do that. I'm going to just do it on 5 and 6 here. So there's my hypotenuse on 5, and here's my hypotenuse on 6. I'm going to use blue for my shorter side. This is my shorter side. It's across from my 30-degree angle, and I'm actually going to write short. And then it's actually in the same spot on the next one. Here's my shorter side, and I'm going to go ahead and write. That's my shorter side, which means by process of elimination, this is my longer side. This would be my 60-degree angle. This is my longer side. Okay, so in each of these problems, we want to remember a couple of things. The hypotenuse is equal to 2 times the shorter side, and the longer side is equal to the shorter side times the square root of 3. And these are sort of our formulas. So if we look at number 5, u is the hypotenuse. That's going to equal 2 times the shorter side, which in this case is going to be 2 times 2, so u is going to equal 4. Now I need to find the value of v, which is the longer side. So the longer side is going to equal the shorter side times the square root of 3. The longer side is v, that's what we're looking for. The shorter side is 2 square root 3, and we have the length of v. Okay, on number 6, we are just trying to find the longer side. So I'm going to start by saying that the longer side is equal to the shorter side times the square root of 3. The longer side is x. The shorter side is root 3. We're multiplying that by the root 3 from the formula. That's going to give us x equals the square root of 9, or x is equal to 3. All right, I'm going to encourage you to pause the video and try to do numbers 7 and 8 on your own. See if you can figure out even just one of the two lengths. Make sure you identify hypotenuse, shorter, longer, and then unpause the video and work through them with me. All right, I have identified the pieces, hypotenuse, shorter, and longer. On number 7, I know the length of the longer side, so I'm going to start with that. The longer side is 9. And I'm going to use this formula. That's equal to the shorter side times the square root of 3. And in this case, the shorter side is what I'm looking for, x times the square root of 3. If I divide both sides by root 3, I'm going to get that x is equal to 9 over root 3. But we know we can't leave it like that. We need to multiply by root 3 over root 3 to rationalize our denominator. That's going to give us x is equal to 9 root 3 over 3, which means that x is equal to 3 root 3. Now I need to find y, which is the hypotenuse. So the hypotenuse, or y, is equal to, according to our formula, 2 times the shorter length, which is going to be 2 times 3 root 3. When we multiply, we just multiply these scalars in front, so we're going to get that y is equal to 6 times the square root of 3. All right, last problem. The piece of information that we're given is the hypotenuse, so let's start with that formula. The hypotenuse is 2 times the shorter side, so 22 is 2 times the shorter side is y, so y is going to be 11. The longer side is going to be the shorter side times the square root of 3. The longer side is x. The shorter side we just found is 11, and that's going to give us 11 root 3 as that other side. So again, I really recommend that you start by writing down the formula, that you plug in what you know, where you know, and then you isolate the piece that you're looking for. Let's look at a couple more complicated examples and then wrap up this video. All right, last two problems. Number 9 says the road sign below is shaped like an equilateral triangle. So the first thing I'm going to do is, they just said equilateral. That means all 3 sides are going to be 36 inches. Estimate the area of the sign by finding the area of an equilateral triangle. So in order to find the area of a triangle, we know we need 1/2 of the base times the height. We also know that if this is an equilateral triangle, all of the angles are 60 degrees. We know that the base is 36, so area is going to equal 1/2 of 36 times the height. So what we need to find is the height. We need to find this length here. So let me see what happens. I'm going to just redraw this triangle. There we go. If I redraw this triangle, I actually have a special right triangle. This angle would be 60 degrees. The hypotenuse we know is 36. And we are looking for the length of the longer side. Well, the shorter side we know is going to be just half of that because the hypotenuse is equal to twice the shorter side. So 36 is 2. I'm going to call this x for now. 2x. So x is going to be 18. So this side length is 18. The height is going to be the longer side, which is the leg, or the shorter side, not the leg, the shorter side, times the square root of 3. So the height is going to be 18 root 3. So we can plop that in here. Half of 36 is 18. and then the height is 18 root 3. 18 times 18 is 324, so the area is going to be 324 root 3 units squared. And there we have it. For number 10, it says a tipping platform is a ramp used to unload trucks. How high is the end of an 80-foot ramp when A, the tipping angle is 30, and B, the tipping angle is 45? So let's go ahead and start by drawing the triangles that we're going to need to do part A. So here I have my 30-degree angle. I'm also going to note that the ramp itself is 80 feet, and that's not going to change. And then what I want is I want the height. So I want this side. Well, this is going to be the shorter side. The shorter side times 30, 60, 90. So the shorter side times 2 is the hypotenuse. So in this case, 2 times h is 80, which means that the height is going to be 40 feet for number 1. So if the tipping angle is 30 degrees, the height will be 40 feet. I'm going to encourage you to pause the video, draw your picture for part B, and then unpause the video and see how you did. All right, so I know that the ramp is 80 feet. I know that if this is a 45-degree angle, both of these are the same size. And I know that in a 45, 45, 90, the hypotenuse is equal to the side times the square root of 2. So 80 is going to equal the leg times the square root of 2. So x is going to equal 80 divided by the square root of 2. And now I need to rationalize that denominator. That's going to give me 80 root 2 over 2, which is 40 root 2 feet. So if the tipping angle is 45 degrees, the height of the ramp will be 40 root 2 feet. Let's go ahead and wrap up this video. This video was about special right triangles, 45, 45, 90, and 30, 60, 90. We learned the relationships between the side lengths, and we did a bunch of practice problems finding one side given another. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.